Hello everyone and welcome to Tech classes. In our last video, we have started the fourth stage of AI project cycle, means data modeling. We have already covered the rule-based approach of data modeling, and today we will learn about the learning-based approach with its types supervised, unsupervised and reinforcement learning. In supervised learning, we will learn about the classification and regression algorithms, and in unsupervised learning, we will learn about the clustering and dimensionality reduction algorithms. And in addition to this, we will also learn about the last stage of AI project cycle, means evaluation. So without any further ado, let's start the video. Have you ever collected the seashells near any sea beach? Sometimes we collect a lot of seashells and then we segregate them. Do you know the names of different types of seashells? I'm sure you don't know. Even I don't know. We just segregate them on the basis of their color, shape, size, or their make. And the learning based approach that we will study today also works like this. In learning based approach, the machine learns by itself. We just feed a lot of data into it, and from the data, the machine creates its own rules. And then it trains itself with the help of the data that we provided and the rules that it created. Here, the rules are not decided by the programmer. They are created by the machine on its own. In this case, the machine adapts the changes in data and recreates the rules to follow the updated data. Means, in machine learning approach, the developer feeds in data along with the answers he requires from the model. And now the machine designs its own algorithm to match the data and the answers and gives out the rules. The model modifies itself according to the changes which occur in the data. Remember, in our last video, we have learned how rule-based approach works to identify an image of an apple or a banana. We have seen how we provide labeled images along with the rules to identify an image, and then the model could identify the image. We also learned that this model cannot adapt the changes in data and it cannot improve itself from the feedbacks. On the other hand, in learning-based approach, we provide a lot of unlabeled images of apples and bananas to the model. Then the model creates its own rules by observing the pattern of the images and learns to identify these images. Here, the rules are not given by the programmer. And to test the model, if we provide an image of an apple to the model, then by observing the color, shape or the pattern of that image, it will place the image in its correct group. Here the testing data can be different from training data. Means, suppose if we provide the model with a different fruit image like a pineapple, then the model will learn about this new fruit on its own and will create the separate category for this fruit also. Means the model is adaptive to the changes in data and it improves itself from the new data. Now, one such example is given in CBSE handouts also. Here we train the model by using 1000 images of stray dogs of any particular area. And to learn from these images, the machine creates its own rules. And by observing the color, size or the fur style of those images, it creates different clusters for different types of dogs. Now comes the types of learning based approach. There are three types of learnings: supervised, unsupervised and reinforcement learning. The very first is supervised learning. In this case, we use label data for training the AI model. We give labeled input data along with our desired output. Now the machine designs such an algorithm that create rules to understand the relationship, trends, patterns, or the structure of the labeled data and then provide us with our desired output. Now, depending on what type of data we are using for training purpose, the supervised learning model uses two types of algorithms, classification and regression. Classification algorithms are used when we are using discrete data to train the AI model, and regression algorithms are used when we are using the continuous data to train our model. Remember, we have already studied about different types of data in data acquisition stage. Let's quickly revise the discrete and continuous types of data once. We can't break the discrete data into fractions. It is represented in integers only, just like the number of employees or the number of students. And also the discrete data can be categorical in nature. Like there can be three possible values for grades in a 3-point grade system like A, B and C. There can be two possible values for gender like male or female. Now if I talk about the continuous data, it can be divided into fractions like the salaries of the office employees. It can be defined in a range like the height of students in a class. The height may range between 5 feet to 6 feet. Now there can be infinite possible values between 5 feet and 6 feet, right? Now coming back to the first type of algorithm used in supervised learning models, the classification algorithms. The classification algorithms work on discrete data. We provide labeled data for training these models. For example, gender of a student can be labeled as either male or female, means data is classified as per their labels. As we can see in the diagram, red dots represents one class of labeled data and yellow dots represent some other class of labeled data. So, some of the examples where classification algorithms are used can be to identify fraud detection, image classification, consumer retention, or diagnostics. Now, the second type of algorithm that are used in supervised learning models are the regression algorithms. Here we provide labeled data that is continuous in nature. For example, salary is a continuous data. Now, if we want to predict the future salary on the basis of previous salaries, then we will use the regression algorithms. If we have to analyze the population growth or forecast the market trends or predict the weather situation, then in these cases we can use the regression algorithms. Second type of learning based models are the unsupervised learning models. In these models, we use unlabeled data. As data is not labeled means data is unknown. And now the machine tries to identify relationships, patterns or trends out of this unknown data. If we provide 1000 images of different types of unknown flowers to an unsupervised learning model, then after training, the model learns to identify them on the basis of their pattern, color, shape, size, number of petals, or other features. Unsupervised learning models use two types of algorithms, clustering and dimensionality reduction. In case of clustering, we provide a very large amount of unlabeled data to the machine. Now the machine tries to find the patterns in the data on its own. The machine then determines its own set of categories by grouping similar data. This process is known as clustering, means grouping of similar objects into one category. Well, some examples where clustering algorithms can be used are recommendation system, target marketing, consumer segregation, and a lot more. Now comes dimensionality reduction algorithms. Dimensionality means the number of features in the input data set. For example, if we want to store information about student, then we can have columns like the name, address, father's name, mother's name, phone number. These are called the data features. We can also call them the columns of our data or the variables of our data set. And if there are 50 columns in one data set, then dimensionality of that data set is 50, right? Or if we take another example of a person's image, and if his image has 20 features like color of his eyes, complexion, face shape, hair color, etc., then now the dimensionality of this data set is 20. Now, from a data set with a very large dimensionality, if we reduce unwanted or useless features, then this is called dimensionality reduction. Means it is a way of converting the higher dimensions data set into lesser dimensions data set. Here we need to be very careful that we don't have to remove any important feature from the data set. We can use dimensionality reduction algorithms in the areas like cognition, signal processing, bioinformatics, data visualization, or noise reduction. A human being can work on 2 to 3 dimensions at the most. On the other hand, a machine can work on many dimensions at the same time. But to reduce the complexity of large dataset, we reduce dimensions. And after a certain level, if we further reduce the dimensions, then there is a risk to lose important information also. For example, the earth is spherical in shape, means its actual shape is in 3 dimensions. If we observe its 3D model, then we will be able to understand all the aspects of earth. But if we reduce it to 2 dimensions, then obviously we are going to lose many important informations about it. Now we can see just one part of the earth. We don't know about what is there on the back of it. We are losing information about its mountains, rivers, oceans, and so many other things, right? Means we always have to be very careful while reducing the dimensions. Now comes the third type of learning model, means the reinforcement learning models. These algorithms work on reward and punishment method. Positive behavior is rewarded and negative behavior is punished. When we are playing a video game, what happens when we mess up? We probably lose points or a life. And what happens when we defeat an enemy or reach a new level? Maybe we get more points or a new tool or a new feature. Some more examples of reinforcement learning are real-time decision making, robot navigation, learning tasks, gaming skill acquisition, or traffic analysis. Now, once we have created an AI model and then trained it using training data, then comes the most important stage of AI project cycle, the evaluation stage. In this stage, we test the working of our model. For testing the model, we use testing data. During data acquisition, we collect a lot of data. And out of that data, we use some data for testing purpose. After testing, we calculate the efficiency of our model. And to evaluate the efficiency of our model, we calculate 4 parameters like accuracy, precision, recall, and F1 score. Well, we will study about the complete process of evaluation and about the calculation of these four parameters in our future video. So with this, we have finished the 5 stages of AI project cycle, and in our next 2 videos, we will cover the 2 important algorithms of machine learning, the artificial neural network and the decision making algorithms. So that's all for today. Thank you so much for watching. See you in our next video. Till then, take care and bye bye.